at Talent Neuron, you're collecting over 700 million job posting data points daily.
Mhm.
And then you're using language modeling methods to deliver insights, which you've said previously 95 million daily predictions based on 700 million job posting data points. And obviously, each of those job posts has a huge amount of information on it.
Yeah.
So, can you tell us a bit more about that work? Obviously, you can't go into maybe proprietary details, but kind of linking the history of what you've been doing, what you cover in the book, to what you're doing today.
Yeah, this is this is why actually I by the way, I'm working at Talent Neuron, but I didn't join Talent Neuron. I joined the company whose name was Wanted Analytics, and this was a local Quebec City company that was created by a local Jan Delil, who is an entrepreneur here from Quebec City, and when I joined, we were about 40, like probably 30 people. And 2 or 3 years later, the company was acquired by a multinational American consultant called CEB. And we were under CEB probably for another year or two. And then CEB was acquired by Gartner. So then we were under Gartner for another 2 or 3 years. And now Gartner, 2 years ago, Gartner sold our business as a separate entity. And this is how I end up working at Talent Neural. So basically, I changed four companies without changing my chair. This was quite funny. So the product that we have is based on the goal is to provide actionable insights to people responsible for recruiting or workforce planning in enterprise. How we do it is that we have robots that go to different corporate websites, job boards, some aggregators, applicant tracking systems. Those sources that contain jobs, we call them jobs. Like it's job posting. When you look for a job, you open something and it says like the title is this and this is the description, the conditions, and so on. So we download these postings daily. So we have about, I think today, about 35, 40,000 such robots. And though these robots, they are not, intelligent. They are fixed. So basically, they know how the specific website works. So they know what to click to go to what page. They detect that something changed, and they download based on some predefined rules. And for most part of my history in the company, my team was responsible for post download. So when the job is already in your database and you have to normalize it or extract something from it. So we worked on all sorts of projects. For example, a typical job posting contains skills. So we created a system that detects different skills in the job posting, extract them, normalize them, because sometimes it's written, for example, I don't know, Java space script. Sometimes it's JS, sometimes it's JavaScript one word. So we need to detect that it's all the same skill. Sometimes it's funny when they say you must excel in Word. So in this case, Excel is not actually a skill, but Word is. So there are plenty of interesting NLP, natural language processing challenges here. So since the first language models have been released, and probably you know about BERT, Roberta, like it's the first transformers that Google released BERT, and then Facebook released Roberta. So these were language models like of what we call encoder language models. So they cannot talk. Okay, they cannot be used to generate text, but they understood text very well. So we adapted these first transformers probably somewhere around 2018, 2019 to, for example, predict the industry. So like the job talks about the company, and from the company description, the model can predict what industry it is. or those models also are good as classifiers. So if we want to distinguish Excel in one context versus Excel in different context, we can train such transformer to actually read not just the word Excel itself, but its surrounding in the text, and make a prediction. Then it's all become multilingual. Like previously, historically, machine learning was monolingual. So if, let's say, you wanted your we had a salary extractor, for example. So we supported about 25 different languages. So for each language, in the past, we created a salary extractor for this specific language. So we really needed to label examples in Chinese, in Japanese, in Russian, and so on. But now today, it's all so much simplified. And again, it's just very recent trend that most of models that are being released, they are now multilingual. And it's like it's for me, like even 5 years ago, no, 5 years ago, probably I wouldn't be surprised, but 10 years ago, like if you tell me that, the same model can accept whatever language it is and output whatever language you want, you would say, no, it's crazy. It cannot work like this. But today, this is what we have. And now, for example, for extracting the salaries for every new countries that we add, we don't label the data for these new languages by hand anymore. We don't label probably at all. We just reuse already labeled data for other languages to train the model for this new language, because like a salary, it's a salary. So no matter what language you use to describe it, it's still a salary. And the models are really strong now to generalize across languages. So this is so this was like post download, but now we also work a lot what we call like uh, before downloads. For example, those robots that I mentioned that come to some website and find the jobs to download. So now we work on a system that builds these robots automatically from scratch. Basically, you just say, here is the home URL of a corporate website. Go find the career section, identify where the listing, like where all the links to the jobs are, create rules to extract different elements from this listing, for example, the title, the location, the posted date, and then click on those links, visualize the description, and extract the description itself. And if it contains any additional attributes like industry or perks and so on, also create rules for extracting this. So now we don't have to create those scripts or robots manually, because historically, again, it was very difficult for our software engineers to automate every specific website, because all websites are different, programmed using different technologies by different people. Some are programmed well, some are less well, some are really ugly. So like our developers really struggled to create those scripts, and especially fix, something small changes on the website, the robot is no longer capable of gathering information. So you have to open the script, look inside, what happened, why it's no longer working, and so on. And now with this automated script creation, we can automate at least half of the websites like fully, and for the other half, it's still manual work. But those websites, we consider them challenging, and challenges are usually more interesting for humans to solve than just something routine.
Yeah, you're giving a great example there of the kinds of capabilities that the large language model revolution is unlocking for us. There's so many things that now can be done in an automated way, like you're saying there. Half of the of the time, you can identify on a website automatically what the formatting should be like and download it, as opposed to having to hand code it. And I'm sure that that percentage is going to go up and up over the coming years.
Well, yeah, but there is a lot of excitement. I think probably, well, you definitely follow this media uh, craze and hype around AI, automated agents that they will solve problems for us. Um, like as I mentioned, well, we have an extensive experience now in trying to use those LLMs out of the box to help us in organizing or extracting information. And it's not as beautiful in reality as it is in presentations. And the problem is that the LLMs are really good at the problems that we call in distribution. And in distribution means that the problem that you ask it to solve, it's similar to what to the data that the LLM saw when it was trained. And the problem for businesses specifically, maybe for particulars, it's less of a problem, but for businesses, the problem is that we don't know what is in distribution and what is not. Because to know it, you actually has to have access to the entire data set that was used to train the model. And this data set is hidden. Like probably for with a couple of exceptions, all LLMs, including those that we call open weight, they are not really open. So you can use them, yes. You don't even have to pay them often, yes. But you cannot really tell whether your specific business problem is in distribution or not. So you can test. For example, let's say you develop a system based on LLMs, and you provide some tests, okay, so some inputs, and it's kind of cool. You give it a problem, it solves it, you see the solution, makes sense. But when you put it in production and real situations start happen, not those that came from your head that you decided that it would be a good test, but real data. And this real data may not be aligned with how you think, what you think the data will in production will look like. And in this case, the LLM can become arbitrarily wrong, or make wrong decisions, output wrong information. And because we don't really have any detection mechanism, and of course we don't have any prevention mechanism. So when you put systems that are based on LLMs in production, this is where the nightmare starts. Because like while you are coding, testing in your controlled environment, and you are happy, everything is good. But then you put it in production. What does it mean in production? In production means in front of the users. And this is where you start getting troubles, and users get angry, and you say, okay, we will fix it, but you have no idea how to fix it because you're blind. You know that it doesn't work, but you have no idea what to do to make it work, because like how close it is to the distribution. Maybe it's just close enough, and you will just add a couple of examples and it like to fine tune it, and that's it. Or maybe the use case was so far from the distribution that no matter how many examples you give, there will be always cases around this place that will still not work. So this is where I really like recommend anyone with the decision power listening to this podcast is to think twice, maybe even uh, 3 times or maybe 30 times before you actually decide to put something LLM based in front of your users, because it might sound cool, like, oh look, we use LLMs, but then they lost reputation and angry customers. This is not something you will find cool.